Good day, everyone. I will be discussing post-hoc test, specifically the Duncan's multiple range test. And we all know that the analysis of variance is a powerful tool for testing the homogeneity of the means. However, if we reject the null hypothesis and accept the alternative hypothesis that the means are not equal, we still do not know which of these population means are equal and which are not. So to determine which means are equal and which are not, we will use a post-hoc test. So for this discussion, we will consider one post-hoc test, which is the DMRT, or the Duncan's multiple range test. And since we already discussed this example in illustrating the one-way ANOVA, and we have decided to reject the null hypothesis, right, for this example, and concluded that there is a significant differences among the 5 mean number of hours of relief provided by the different brand of tablet. So to illustrate DMRT in this example, kay gi-reject man nato ang null hypothesis. First is we will compute for so number 1 step, we will compute for S sub x, and S sub x here kani siya, kani nga formula. Since this is R sub p and then multiplied by S sub x bar, so kani nga formula muli ito ang S sub x. So let's compute for S sub x bar equal to the square root of S squared here from our table, that is the mean square squares from the error, or mean square error. So that is equal to, from the table, that is equal to 2.88. And then n here is the number of n. So dirita, since di ba mo niya to ang k, so each k is, we have n. So that is the number here. So pila man ni kabok, 1, 2, 3, 4, 5. So that is 5. So to compute that, we have the square root of 2.88 divided by 5, and that will give you 0.76. And then for step number 2, we have here, we will have a table for P. We have R sub P, and we also have R sub P, or the capital R sub P. So from this, okay, so for P here, from the Duncan PDF that I have provided you, that is the new multiple range test table. So from there, we have this. Okay, so P here will make use of P2, 3, 4, 5. Since we have n equal to 5 here, so up to 5. So we'll start with 2, since we are comparing 1 to 2 to 3 to 4 to 5. So the Duncan's multiple range test will start with 2 always, and then it will depend on the number of n here. So we have 2, 3, 4, 5, and then R sub P, since the degrees of freedom for the error is 20, so we will look at this. So those values. So we have 2.95 for RP, R sub P, small r sub P, 3.097, 3.190, and 3.255. Okay, so we have here 2, 3, 4, and 5. So for R sub P, that is, okay, so this is from the table of Duncan's multiple range test. So this is 2.95. So degrees of freedom is 20. This is S sub 2, S sub 2, yes, S sub 2 squared, and 2.88. So ito na siya sa mean square error. So we have the degrees of freedom there equal to 20. And then for 3, this is 3.097. And then 4, 3.190. And then 5, we have 3.255. Okay, and then we will compute for the capital R sub P, or the least significant range for the P mins. So the formula for that is equal to here, from here. So multiply lang daw nato na ang R sub P kani siya dito sa inyong S sub X, or 0.76. So we have 2.24, 2.95 times 0.76. We have, sige, ako lang isulat, 2.95 times 0.76, and then 3.097 times 0.76. That will give you 2.35, and then 3.190 times 0.76. That will give you 2.42, and then 3.255 times 0.76. That will give you 2.47. So after that, we'll proceed with step number 3. Step number 3 is to arrange all the means in descending order. So, sige, arrange means in descending order. So, unsa ito atong mga means? We have, sige, from the previous example, x sub 1 bar is 5.2, kani siya, 5.2. X sub 2 bar is equal to 7.8. X sub 3 bar is 4.0. X sub 4 bar is 2.8. And then X sub 5 bar is equal to 6.6. Next, okay, so we have the following means in descending order. So gikan sa pinakataas padulong sa pinakaubos. So we will have pinakataas diri is 7.8. So 7.8, and then sunod is 6.6, and then 5.2, is x sub bar 2, x sub 5 bar, no sorry, x sub 2 bar, x sub 5 bar, and then we have x sub 1 bar, x sub 3 bar, and x sub 4 bar. Okay, so after arranging all the means in descending order, step number 4 is to arrange also the r sub p next to its mean in descending order. So, ang pinaka taas dire na r sub p, so if these are the means, and then r sub p in descending order po. So we have r sub p is mauna si 2.47, and then followed by 2.42, 2.35, and 2.20. Sorry. That is 2.24. So, wala ni sulod diri. Okay, since 2, 3, 4, 5 raman ta. And then, ang RP na to, isupat raman ni siya. Okay, mag-start man ta kan 2, 3, 4, and 5. So, normal niya siya nga wala ni sulod diri sa ubos. Okay, next. So, this is step number 3. Step number 4 is to arrange R sub P in descending order also. And then step number 5 is to compute for D. D here is mean minus R sub P. So, dirita. Pwede na po na ito i-abay diri para dili mo malibog. So, D, so ang mean minus R sub P, so this is 7.8 minus 2.47, that will give you 5.33, and then 6.6 minus 2.42, that will give you 4.18, 5.2 minus 2.35, that is 2.85, and then 4.0 minus 2.24, that is 1.76. Okay, so we will give each D a code here. So let's try small letter A, letter B, letter C, and letter D. Code lang ni siya ha, para later mabala na to kinsa ang significantly different with the other and not significantly different. Okay, so from there, step number 6 is to draw a conclusion out of the computation. So how will we compare each? Okay, so let's compare the means. So let's compare the means here with the D computed. So since we are using the codes here A, B, C, and D, so bear with me. So let's compare 7.8 is 7.8 greater than 5.33. If the answer is yes, then we will label this as A. Next is 6.6 greater than 5.33. The answer is still yes. So we will still label it with A. Next, we have 5.2. Is it greater than 5.33? Since this is lesser than 5.33, then we'll stop here. Since descending order man ni siya, so si 4.0 sure na nga mas gamay po siya kang 5.33, and also with 2.8 mas gamay po na siya kang 5.33. Next, so we'll done okay na ta dire 7.8, so diri ta kang 6.6. Compare na po nato na siya didto kang B. So is 6.6 greater than 4.18. So kay mas dako man siya, so label po nato na siya B. Next, 5.2 mas dako ba kang 4.18. So kay mas dako man si 5.2 kaysa kang 4.18, then label po nato na siya B. Next is 4.0 greater than 4.18. So mas dako man yung 4.18 kaysa sa 4. Mas gamay si 4, so this is not true. So we'll stop here. So diri ra ta. Also 2.8, sure naman po na nga mas gamay po na siya kang 4.18. So okay na ta dire. So let's have 5.2. So 5.2 dito bangga sa iyahang across lang. Di na ta mo balik dito sa A and B kay sure naman na siya nga mas gamay si 5.2 sa ilaha. Or sorry, mas nahuman naman ta na kaganina, diba? Dirita kang B and kang A. So let's start with 5.2 compared to 2.85. Is 5.2 greater than 2.85? Yes. So label nato na siya C. 4.0 greater than 2.85? Yes, also. 2.8 greater than 2.85? No na, kay this is 0.05 higher than 2.8, right? So stop na ta. And then we have 4.0. So 4.0 mas dako ba kang 1.76? Yes. So label with D po na siya. Is 2. No, sorry. So is 2.8 greater than 1.76? Yes. So okay na. Tayo label dire. So this label will tell you that we have x bar sub 2 and x bar sub 5 are not significantly different. Tama? Diri ka. X2 and X5 kana silang duha. Nganuman, pareha man ni sila na A. So meaning silang duha wala ra nagkalayo ilahang means. Okay? So basta naa gani kay kapariha dito sa pikas, then dili na sila or they are not significantly different with each other. Next, how about x sub 2 and x sub 1? So, direta, x sub 2 versus x sub 1. So, sa inyo hang makita dire, x sub 2 and x sub 1 are kani, A ang iya, dire kang x sub 1 is B na. So, wala sila common duha. So, kaya wala sila common duha, si x sub 2 and x sub 1, then they are significantly different. Nakuha? So, as klaro nga significantly larger si x sub 2 kang x sub 1. Also, we have significantly larger po siya kang 3 and kang 4. So, si x sub 2 bar is significantly larger, or the means from here, kani ang mean dire, this is x sub 2, right? X sub 1 man eh, x sub 3 bar, x sub 4 bar, and x sub 5 bar. So, klaro nga si x sub 2 daw, or the mu, let's call it the population mean sub 2 is greater than population mean sub 1, also with mu sub 3 and mu sub 4. Okay? Kana. So, next, how about x sub 5 and x sub 1? Kani x sub 5 and x sub 1. Kani x sub 5 and x sub 1. Naman sila common duha. So, you can conclude that x sub 1 and x sub 5 are not significantly different. Okay? Na may common sa ilahan duha kani si B. Common nila. Munang gigamitan nato label kaganina to identify aha ang significantly different and which are not. So, how about x sub 5 and x sub 3? So, x sub 5 and x sub 3, kani. So, diri raman ang common no, kang bilang man ang common. So, x sub 5 and x sub 3 doesn't have a common. Bira ko taman diri. Diri kang x sub 3, nagsina ko. So, x sub 5 and x sub 3 are significantly different. Nakuha? So, that means mu sub 5 is significantly larger than mu sub 3 together with mu sub 4. Kaya paubos man ni, right? Naka-descending order naman ta. So, next is we compare x sub 1 and x sub 3. Ano siya? So, is x sub 1 and x sub 3 na by common? So, kay common man si C, then we can say that x sub 1 and x sub 3 are not significantly different. Okay? And then, not significantly different man. So, let's proceed with x sub 1 and x sub 4. So, nabay common si x sub 1 and x sub 4 in terms of label. So, kay wala man, then we can conclude that x sub 1 and x sub 4 are significantly different. Or you can say that mu sub 1 is significantly larger than mu sub 4. And lastly, we have x sub 3 versus x sub 4. So, since naman sila common duha, then we can say that x sub 3 and x sub 4 are not significantly different. So, kung gusto po ninyo maklaro ninyo ni nga label, so pwede man nato ni siya buhaton kay x sub 2 bar, and then x sub 5, and then x sub 1, and then x sub 3, and then x sub 4. So, tan-awan na to kinsay na common. So, si x sub 2 and x sub 5 na common. Si x sub 5 and x sub 1 na apoy common. So, si x sub 1 and x sub 3 na apoy common. Si x sub 3 and si x sub 4 na common. So, kanang nailinya, they are not significantly different. And then, kung i-compare ninyo ni siya si x sub 2 with the rest, they are significantly different or significantly larger in population mean sub 2 with the other, except for mu sub 5. So, kung kinsay na ay linya, kung aha nagtulong na nga linya, then they are not significantly different. So that is by DMRT, or the Duncan's multiple range test. So if you are asked kung ahas sa population means ang significantly larger with the other or significantly different with the other, then you can use DMRT to show or to illustrate that, or to identify which of the population means are different, significantly different with each other. That is, kung ma-reject si null hypothesis using one-way ANOVA. But, okay, so let's proceed with the next example for illustrating the one-way ANOVA. So we have here example number 2. 6 different machines are being considered for use in manufacturing rubber seals. The machines are being compared with respect to tensile strength of the product. A random sample of 4 seals from each machine is used to determine whether or not the mean tensile strength varies from machine to machine. So the following are the tensile strength measurements in kilograms per square centimeter. So we have the following data here, So perform the analysis of variance at 0.05 level of significance and indicate whether or not the treatment means differ significantly. So let's try. So let's identify the given values here. So we have K equal to 1, 2, 3, 4, 5, 6 different machines, and then for each machine we have N equal to 1, 2, 3, 4 for sample. So from here we will compute for the total for each column, right? So total here is 68.8. Second column is 68.7, and then we have 72.7, and then we have 71, we have 73.7, and then 72.1. The total for all of the total is 427. Okay, next, let's compute for the mean for each column. So 68.8 divided by 4, that will give you 17.2. 68.7 divided by 4, that is 17.175. And 72.7 divided by 4, that is 18.175. 71 divided by 4, that is 17.75. 73.7 divided by 4, that is 18.425. And then 72.1 divided by 4, that is 18.025. And the total, not the total. We have 427 divided by 24, since 24 mani kabuok, so 427 divided by 24, that will give you 17.79. Okay, so from this, step number 1 is to state the null hypothesis and the alternative hypothesis. So since we are having 6 case here, so we have mu sub 1 equal to mu sub 2 equal to mu sub 3 equal to mu sub 4 equal to mu sub 5 and equal to mu sub 6. So that is the means, the population means are equal. Next, H sub A, or the alternative hypothesis, then that is at least 2 of the means are not equal. Step number 2, we have the level of significance to be used is 0.05. Step number 3 is, this is one-way ANOVA. Step number 4 is to establish the critical region. So for the critical region, Um, all right. So the computed value of f greater than the tabulated value, where v sub 1 here, so may v sub 1 na to, that is k minus 1, right? So v sub 1 is k minus, this is k minus 1. So this is minus 1, that is equal to 5. And then v sub 2 is equal to k times n minus 1. No, okay, tama. So k here is 6, n is 4 minus 1. So 6 times 3, this is equal to 18. So v sub 2 here is equal to 18. So f is greater than, so this is from the f table, and this is equal to 2.77. Di ka ni sa f table ha. Kanya siya. So you should reject HO if the computed value is greater than 2.77. So for the fifth step is to complete the ANOVA table for one-way classification. So we have the source of variation, we have the sum of squares, we have the degrees of freedom, we have the mean squares, and the computed value, or the computed value of f. Okay. Ay. Okay. So we have the column squares. Column means, sorry. Column means we have the error and the total. So let's compute for SSC, SSE, and SST. So for the column means, using the formula, we have SSC here equal to 5.338, or you can have 5.34. Sige. SSE and SST. SST is 62.64. SSE is 62.64. Sorry. Bali. Si SST is 67.978, and then, or you can have this 67.98, then 67.98 minus 5.34, that will give you 62.64. So column means we have 5.34, error 62.64, 64, sorry, and then total 67.98. We have the degrees of freedom, v sub 1 here equal to 5 and v sub 2 equal to 18. Total is 23. Mean square, so 5.34 divided by 5, this is 1.068. Tama ba? And then 62.64 divided by 18, it's 3.48. And then for the computed value of f, that is 1.068 divided by 3.48, that will give you 0.06 or 0.07. So with this, the computed value is 0.306, and you should reject the null hypothesis that all means are equal if the computed value is greater than 2.27, but in this case 0.306 is less than 2.77, so step number 6 is to accept. This is not true. 0.306 greater than 2.77, dili man ni tinuod, so we have to accept the null hypothesis that all means are equal. So since 0.306 is less than 2.77, so we are to conclude here, therefore the there is no significant difference between the mean tensile strength. Ay. Okay. So, kay gi-accept man, then we will not proceed with DMRT to test or to identify which means are significantly different or which means are not significantly different, since we concluded that there is no significant difference between the means tensile strength of the machine. Okay, that's all.